Hello and welcome to KNX Experience 2021. Hello and welcome to Theben. My name is Elmar. I'm Head of Technical Support and Training, and I will convey you through the next approximately 20 minutes about a rather appropriate content which we try to cover with a good and a smart KNX solution. The content of today, or the content of this, let's say, presentation here on the KNX Experience is ventilation control KNX. A rather appropriated content of today. I will give you some insights in regards of the viral load, ventilation, and so on. I will give you some, let's say, insights about how to measure CO2, what is the effect in terms of aerosols, how to manage the air exchange rate, and I will share some insights as well. So in regards of the solutions, so that means how we can integrate hardware, centralized or decentralized hardware into a reasonable KNX solution. You know, when it comes to energy efficiency or health quality, so we have to consider two things. So in regards of health and healthy condition, however, we have to do the airing as much or as often if possible. In regards of energy efficiency, just keep it running as long as needed, as required, however. And so finally, this requires a perfect and a smart ventilation control with KNX. I will share some insight with you. What is the content currently? So we do have, worldwide this problem with these virus infects, however. And due to the ongoing threat environment, gatherings of people in rooms, in schools, however, there is always a risk of to be infected, and probably it might increasing again. So that means a perfect ventilation is required, and this has to claim attention accordingly. But remember your office, your schools, your public buildings, however, but not in any cases you do have ventilation existing. So that means a perfect solution like probably we do have here. So a huge ventilation centralized in an industrial area or in a big school area, however. So due to that, we need probably some decentralized solutions as well. And I will give some insights at the end of this presentation, so how we can integrate and what solutions we do have. Not we do have, but in total, which are existing. The Max Planck Institute, for instance, here in Germany, did some investigations, and they discovered, we can bring down the infection, we can cut down it into halves by regularly, let's say, in-rush airing. So that means window open, natural airing, however, can bring down the concentration of the aerosols, which can finally transport and spread the virus, however. So that means natural ventilation is appropriate and a pretty simple solution, however. So, but be reminded, if just a window is tilted, for the natural airing, is not that rather efficient, which is, confirmed. Just rush and in-rush airing can bring down the, these values to approximately 60%, which is rather good, without any technique accordingly, but you have to care about. So that means you have to announce someone to open the door or the air, the window, however, to get the natural airing finally. Just to tilt a window is not good enough. You need a natural air stream to bring out these aerosols, and specifically the light aerosols. And this institute here, this high school, investigated, so just a tilted window, was so medium efficient, however. To open a window, it's by far better. And if you open either another window or you slightly open the door so that a natural airstream is ongoing, so this is rather efficient. Or if you use just a simple fan, yeah, inbuilt, for instance, in the wall, this could generate as well a natural airstream and can bring down tremendously the load of these light aerosols. So that means natural ventilation has to be preferred, window open or with specific fans, which you know probably from kitchen, from bathrooms, however, which bring fresh air in or which hoovers out, let's say, high humid air. And exactly such kind of ventilation you can use. Quite simple, but highly efficient. And when you, let's say, add such kind of a ventilator into a room, then with this small accommodation, finally, you get a natural stream, air stream, and due to that, you can bring down this virus load in rooms in general, let's say in general. So that means we have to take care about, let's say, this ventilation in general. But additional, there are some other options, finally, which can be done. And some of them are currently as an option to be retrofitted into decentralized airing systems. Yeah, which means by updating or retrofitting the so-called UVC light. You remember what is UVC light? Your ultraviolet light. C is the description for exactly this one here, 200 to 300 nanometers of wavelength. And this light, UVC light, is a little bit difficult. So that means too much UVC light on the human skin can rise the risk to get cancer. Yeah, or probably if you watch or if you steer directly into UVC light, this can damage your eyes. Yeah. Okay, so be aware about that. But this UVC light, the radiation of it, can separate the DNA of viruses in general. So it's an additional tool to bring down that. Yeah. This has nothing to do with KNX, but it's just in the current situation an additional information for you what can be done. So now we come more to the KNX part. Yeah. So that means the air quality measuring and the air exchange rates and so on. So these gentlemen, these scientists, Max of Pettighofen, discovered in the 18th century, so approximately meanwhile 150 years approximately back, so that there is a deep impact from CO2 value in a room, yeah, and the well-being of the people. Do you know, by the way, so when hailing, yeah, so how many ppm, so the parts per million, so it's a value for the CO2 gas, how the value finally is? Any idea? It's approximately 400 ppm in good, let's say, environmental conditions. You know how your value finally is when you're exhaling. Yeah? Any idea? I share with you. So that means we do have here approximately, depends on how hard your bodywork finally is, between 10,000 and 40,000 ppm exhaling of one single person on each breath. You heard right, exactly. So what does it mean? So if I take this chart of the global population, you see here in the 18th century, we had approximately 1 million people on the globe. Currently, we are here, around 8 million people on the Earth. So just due to natural breathing, the CO2 value increases tremendously without any fossil burning. Just to keep this in mind. Yeah, what does CO2 gas affects? CO2 gas affects finally that you get tired, not that well concentrated. Probably you get headache, however, And due to that, we have to care about that. Yeah, it is one of the important things while studying, for instance, in the school, however, or while working in the office, however, to be really attended and attentive, however. And due to that, we have to concentrate, or we have to care about the CO2 values. The effect is finally, so okay, at around 1000 ppm, so we sense it probably as a worse smell. However, about 5000 ppm, I would like to say this is a difficult value because there is a normative regulation which tells us here in Europe, this is the maximum concentration of CO2 under, let's say, working conditions. So latest at this threshold, when this threshold is exceeded, a ventilation has to be started. If higher, so then it becomes difficult, I would like to say. So approximately 100,000 ppm, so naturally a candle will expire. Above 200,000 ppm, so it can be mortally. So that means here depends, highway to hell or stairway to heaven, I don't know, but this is mortally for us. Okay? So be aware about that. And when I talk about these aerosols, this is exactly these small molecules while breathing, while talking. You can't see. While I'm talking now, you don't discover any, let's say, clouds of these aerosols, however. But you can discover if, for instance, you exhaust in front of a mirror or of a polished surface, however. Then you see there is a slight liquid, a slight kind of fog on this surface. And on these, let's say, light molecules or these aerosols, these viruses can be transported, spread while talking and while breathing. The heavy aerosols, they are dropping down on the ground or on the surface of a table. Sometimes probably you discover it while talking, however. But the light aerosols are the difficult ones. And these have to be brought out of the room by a good ventilation management. There is a reasonable, let's say, recommendation, which tells us, so it depends on how the usage of the rooms are. So if just half the value of, or the volume of a room has to be exchanged within 1 hour, or probably in industry, depends on what you're doing there, what you're manufacturing there, however. So probably 25 up to 40 times per hour, the entire volume of the air has to be exchanged to keep the people well attended, however. So there's a natural regulation, and this has to be cared about. And imagine now, to tell some, so you care about the ventilation, open the window when you feel. I think during the normal working process it doesn't make any sense, and it will definitely not work. Due to that, it requires some perfect solutions. For instance, like here, the CO2 sensors, which take exactly this burden and manage finally the air quality control. In this case, we have to distinguish finally, so the systems behind. So we discover here, for instance, this training area, this training center here. We do have here a natural and a centralized airing system. So with a CO2 sensor, we can open a damper, for instance, or we can start the fan if a certain, let's say, CO2 value with a reasonable, let's say, humidity and aerosols, however, is increased. And then we start the natural ventilation, the air exchange. What you discover here, high-scribe building and no windows to be opened. Okay, so that means here are centralized solutions required. Probably you have buildings, older buildings like here, difficult to retrofit some, let's say, centralized solutions. So here probably are decentralized solutions required. Or probably we do have here our, how can I say, the subsequent generation. Not all the schools are in a perfect condition in terms of light control, air condition control or heating control, however. But we have to care as well. We are responsible for the youngest generation. subsequent generation finally, so to give as well for such kind of buildings or existing systems a reasonable solution. So if we take into consideration, so we have to give a solution for industry or for public buildings, however, which are rather well equipped with technique, centralized technique and so on. This could be, for instance, a system like that, so a centralized ventilation system. And we do have here either electric-driven dampers, so you can position the dampers, however, with 0 to 10 volt, and this, let's say, air control or ventilation control, you can perfectly control with the FCA2, which is a fan-coil actuator, heating and cooling, but in this case we use the fan speeds in either 3 steps or stepless, 0 to 10 volt controlled, or you can either, if there is no damper in, but there is a fan which you can control stepless, 0 to 10 volt, so then the FCA2 is the perfect solution finally to give you the reasonable solution. As the couple, so that means FCA as a couple together with the CO2 sensor AMUN from Theben. So with this combination you have a perfect air quality control, the dehumidifying is perfect, the CO2 management is perfect, and if the CO2 management is perfect, so you have in your hand as well, so the management of the aerosols, to bring out the aerosols, to have a good, let's say, air recovery or airing system in your building. Decentralized solutions, which we pretty often find in shops or shopping malls, however, either, let's say, directly linked from here to this centralized solution or standalone, then there are just chillers. So this can be controlled by AMUN 716, but if you don't have any access, for instance, to KNX, to control from the KNX side, so then we do have here as well a solution which is giving you either 3 relays on-off, so in 3 stages fan control, or 0 to 10 volt, it's up to you. Or if we do have finally such kind of ventilation here, mostly decentralized in front of a window, however, and with AMUN we control finally the air quality management as well. So, and the AMUN itself is a controller which is finally the CO2 sensor, like here. So here inbuilt we do have here a probe which is like that. This is a specific one. Through this white, let's say dot here, it's a sheet of paper, a kind of a filter. Through this filter passes the air which is around this sensor, and measured is finally the CO2 value in this specific tube. And at the end here we do have here a specific, how can I say, a specific electronic component which measures finally how the quality, the air quality finally is. And in this CO2 sensor we do have here as well a humidity sensor, so you can either control it on humidity base or on CO2 base, or both together, however, so you can link it together. So if the value is that and the value is that, so then you can manage, then you can do the air management accordingly. And you manage finally then, so these centralized or decentralized airing systems. But if, or what if, you do have buildings finally which are not that well equipped, which not have a centralized airing system. So here is a really simple solution finally with so-called decentralized air exchange systems. In life they look like that, so that means we do have here a ceramic part in this tube, and there are fans hoovering out finally the used air, probably the viral loaded air, hoovering out the warm air stream from the temperature inside, passes through this ceramic center here and blows out, exhausts out finally the used air. But the warm air is heating up finally this ceramic filter. Then, sequentially, so the fan hoovers in the fresh air from the outside, is streaming along this ceramic filter, which was heated up from the exhaled air. And so the hoovered fresh air in is heated up, so that means the gap between the temperature inside and the temperature outside, or the air temperature finally, is not big anymore. So it's a rather energy efficient solution finally. And this, what is required finally? You need a drill bit to make a cutwork through the wall. You put just this tube through, and then it's just required that they do have a reasonable CO2 sensor, and the reasonable, let's say, link or adaptation to the KNX, to a KNX actuator to start, to stop the fan, however, or to turn to fan step 2, however. And therefore you need, first of all, a CO2 sensor, which is our AMUN, caring about CO2, relative humidity. However, if you like, you can measure the room temperature as well and can bring this under control. And you do have here as well, so air pressure. For which purpose we need air pressure? We need it, or we use it, for instance, to self-calibrate this CO2 measuring. So it's out of question for us to recalibrate our sensor after 2-3 years. However, there is no need for it, because in a specific, let's say, a logic controller, we take air pressure and calibrate our CO2 measuring. Okay, smart and clever. And additionally, you get, for instance, in this AMUN 716, you get 3 binary inputs, and these binary inputs, for which purpose you can use? Exactly, you can link it to a window contact, to a door contact. So if a window is open, if a door is open, however, you can stop a process, or however, you can make this, let's say, controller more efficient. It's up to you. Or, this is a rather simple solution finally. Simple. This, let's say, hybrid solution here. This is finally the AMUN 716, inbuilt in a presence sensor, so it's all in one. So that means, first of all, you do have here a presence sensor managing your light control in an office, in a schoolroom, however. And down there, we do have here the CO2 sensor. Give me just a second to open. And then we do have here, just as an example, the CO2 sensor. Here underneath is exactly this tube measuring the CO2, measuring the temperature, and down there we measure, for instance, the humidity. So this is how it looks like, and that means finally this is the all-in-one solution. It just requires a bus cabling, a bus cabling in terms of the wiring to this sensor, and with this single unit, so you can do light management, daylight control, for instance, highly efficient. You can do the management for the CO2 or for the climate, because of temperature probe is inside as well. So most best. Simple to reinstall, to retrofit finally. And then finally what you need an actuator, either, like mentioned, for more the professional solutions or industrial purposes. So we use either the FCA1 to control, for instance, these fans, or we can do finally the perfect solution for the retrofitting, especially for these subsequent generation. So what if, so for this purpose, for instance, we can recommend just solutions like that. So if schools are not equipped with a centralized solution, to give them a really good precondition, a really good condition to work, to study, however. So then it's appropriated and a pretty simple solution finally to make, with a drill bit, to make a cut through, a cut work, put it through, and then you discover here, this is just an example, we do have here a wiring which allows you, which puts you in a position to turn the fan speed from level 1 to level 2 if the contact is closed. And here you do have here the master switch, so on off. So and what you can do finally now, you need an actuator. An actuator from the KNX side, and the solution looks like that. So you do have here, for instance, CO2 Ramses 7/16 from Theben, giving on the KNX side the current ppm value. In this case, for instance, 1500 ppm. So there's a quite heavy load on the CO2 side. So and then I take here an actuator, flush-mounted actuator. Doesn't matter if, let's say, twisted pair or RF, doesn't matter. But I took here, in this example, shutters and blinds actuator. Why this? Because of our shutters and blinds actuator, we can control these two relays totally separate. Yeah? For shutters and blinds, you need the up, you need the down control, but you can set this shutters and blinds actuator as a 2-channel flush-mounted actuator. So how it runs? So first of all, if the first threshold finally is exceeded, so the master contact is closed, so the fan starts the air exchange, exhausting the used air and hoovering in fresh air. So if the value is increasing further on, so the second channel switches finally this contact here. So that means we start now fan speed 2 in hoovering or in exhausting, doesn't matter. Yeah. So why? Because we have here inbuilt as well so-called threshold application. So that means if a specific threshold is reached, then we give a bit command to the actuator to switch on, for instance, the ventilation, or to start the ventilation. If the next value is exceeded, next speed, next fan speed, for instance, is kicked on. Pretty simple, yeah? If you select finally this all-in-one solution, the thePrema with the AMUN 716 inbuilt all-in-one, application is same. Just to set the threshold, you take this actuator with these two relays, two-stage finally, and you can control. In some sophisticated window solution, for instance, they do have here inbuilt in the frame of the window a natural ventilation. Yeah? So that means you can here control the hoovered air and the exhaled air and for the air exchange, and you control it with the two-stage fan control with the JU1 KNX. Pretty simple. Yeah. If you decide, okay, not this one, so my Windows does not have this specific technology inside, so 2 different fans. So then, okay, do a cutout, do this drill bit work, and you put these air exchange systems, wiring, and the setup is same like before. Rather simple investment, so just as a rough idea, such solutions are about between 400 and 800 euros, depends on the size, if 150 or above millimeters in the diameter, and depends on the brand, however, but this is a rough idea. So if you have to retrofit a centralized solution, this is by far higher. So it's in your hands. You decide finally how the options are. If you do find, for instance, a decentralized solution, or if you have to add to retrofit some for schools, for, let's say, oldering buildings, however, so then you know how to do it. And it's rather simple to integrate this in a KNX solution. Or you can go another way. And this is exactly the thePixa. The thePixa is the newest generation of presense sensor. And this presense sensor, here, optical presense sensor, this sensor does not have a CO2 measuring inside. By far not. But this sensor can count people, the amount of people, for instance, gathering here in this meeting room. So it depends on how many people are in. So you can decide when the fan for the air exchange, for instance, shall get started. Pretty simple. Integrated as well window contact so far, if there are windows to be open. So this is another solution. And this, let's say, this optical sensor finally can support the DALI gateway, which is controlling, managing in this nice conference room the natural daylights, or the daylight dependent light control, for instance, or the HCL control, HCL light control. You can, for instance, override it with the app. So our Eon displaying, for instance, values, how is the air quality, how is the humidity inside of the room, can manage it, and with the app you can control this accordingly. And then finally you control the ventilation, either in this case decentralized or centralized. It's up to you, depends on the building you have to set up. Hopefully it was interesting for you. See you next time.